This is one of the most recent reports from the IPCC, and I understand, there are quite a number of Canadians involved in the preparation of this report, and I know Alex and Shanda did reach out to some of those people, but it was too short of notice to get them here. So the report is a summary, so hopefully I can take you through and still kind of hit the highlights, but it would have been nice to have somebody like that here who was very much involved in the development of this report. And they're from Environment Climate Change Canada, either research associates with Environment Climate Change Canada, which we have at a number of our universities in British Columbia, I think. And they're involved also in the next report, which is coming out not till 2022, however. So in the meantime, this report, maybe just a few things about it. It was very much focused at what's the difference between 2 degrees of warming and 1.5 in terms of the impacts to the ecosystems of the world. And second part of it was, what do we need to do to get to 1.5 even versus 2 degrees? You saw from Tyler this morning a little bit about 2 degrees and the IEA view of how they could get there. And you'll see in this report, they're trying to get even lower to 1.5. And so there's that element. But then the other thing that's interesting about this report that I think ties to the interest of the First Nation Climate Initiative is they talk a lot about sustainable development goals. And so the UN Sustainable Development Goals, 18 Sustainable Development Goals, there's a whole chapter on it in this report. And like and then it starts to map those goals against energy. It says, okay, if we're going to meet these goals, sustainability, whether it's clean water, a reduction in poverty, access to energy, and then you go through the list of 18. What is the linkage to energy? And so they have a look at that, and what you see in the report is there's a very strong linkage to energy. So those two things are not separate, and that's what. So that's an interesting part, because part of the FN Climate Initiative is really addressing that as well. Well, we want an opportunity to participate in the economy, but we want it to be in such a way that's contributing to get to this lower carbon emissions. So it's the sustainability issue. Some of the slides get kind of redundant, where they're kind of we're going drilling down. So I'll skip through to get to the key points. And then after this report is very much a global thing. So it's talking about what do we need to do to get to 1.5 as a globe, and so it's kind of like, well, how can that be? It would be nice to kind of boil that down to what does it mean to Canada or to British Columbia? And so at the end of this, I take a crack at that. So it's my view, what does this mean for Canada? And so I have a series of slides at the end where I said, okay, it's one thing to go through this report and understand what impacts, what we need to be doing, and sustainability, what are the key things that link to those pathways to give us the strongest pathways. And that was like, okay, now let's look at Canada and what does that mean for us. So I've taken a shot at that, and it's a separate presentation that's only about 8 slides long. So this report was released in 2018. Special report on the impacts of global warming, 1.5 degrees C above pre-industrial levels as a goal in the context of strengthening the response, so to the climate change risk. Also sustainable development and efforts to eradicate poverty. So those elements are very strong in this study. It's not just about climate change, sustainable development and poverty eradication. There's the report. People inputting, 91 authors from 40 countries, all that good stuff, 1,000 reviewers. Interestingly enough, I did go back and look at the Canadian input. It's pretty strong in this report. And then I was saying to Shanda about where I found it strongest is on impact assessment. So if it's about impact to Arctic, impact to ice melt, impact to oceans, impact to fisheries species, and terrestrial impacts in North America. Very, very strong science from Canada. I didn't see, the second part of the report is the pathways, which I felt that I didn't see as many Canadians involved in that. although there are some Canadians involved in that as well. But anyways, I'll do my best to take you through this, but I'm not the expert in this one. I'm more like the messenger, so please don't shoot the messenger. Similar theme to what we heard in my earlier presentation this morning, it all matters, every year matters, and all of our choices for mitigation matter. I think we saw a lot of this in my presentation this morning around where our industrial emissions are. What we saw was we're above that, that natural, oscillation of CO2 emissions. We've gone above it. Our data this morning from NATO showed 0.8 degrees Celsius of warming. These guys say approximately 1, so they've rounded up. But what they go on to talk about is the consequence for people, nature and livelihoods, as well as projections on when we might hit 1.5 degrees C. So they're saying by 2030 to 50. And then it says past emissions, so where we are, don't commit the world to 1.5, meaning if we could turn it around, if we stopped right where we are in our tracks. I think that's what they're saying. So then the first part of the report is climate change, potential impacts and risks. In a summary, impacts, and again, this report wasn't a sort of an all-in assessment of impacts so much as what is the difference in impact between a 2-degree world in the future and a 1.5 degree look like. And so some of these are relative. So we say less. So obviously at 1.5 versus 2, it's going to be less extreme weather where people live, including heat and rainfall. Sea levels would rise less by around 10 centimeters, and which means 10 million fewer people were exposed to the risk of rising seas. And then also on terms of 1.5 versus 2, lower impact on biodiversity and species, smaller reductions on the impacts to agricultural crops for food, maize, rice, and wheat, and less impact on water shortages for global populations, less by a lot, 50% less risk on that piece. So this is all very high-level relative stuff. We'll get to some of the details underneath this later in the presentation. And then similarly, lower risk to fisheries, if we can stay at 1.5 versus 2, and then up to several 100 million fewer people exposed to climate-related risk. Again, that would be coastal and maybe drought, and susceptibility to poverty by 2050. So those are the high-level statements. Emission pathways and system transitions consistent. So these are sort of high-level findings, and then the presentation starts to go into deeper diving here. So this is more about now the pathways consistent with 1.5. And what they found was to limit warming to 1.5, emissions need to fall by 45% by 2030. And then at 2050, they need to hit net zero. So I think that's a little more aggressive than what we saw in the IEA, where the IEA is looking at roughly a 50% reduction by 2040, I think was kind of, or maybe a little more, 60%.
The 1.5 to 2, the question is really when do you achieve net zero, not if you achieve net zero. So in the Sustainable Development Scenario, they achieved net zero a little bit later than 2060.
Okay.
And then the IEA has a 1.5 degree scenario, and they achieve net zero by 2040.
Yeah, and I think we'll see it here, but they also conclude, it also talks then, to get to 1.5, you need unprecedented scale, change at unprecedented scale, deep emission cuts in all sectors, a range of technology, behavioral changes, increased investment in low carbon options. I think it's interesting, you'll see, because their scenarios go sub-zero. So it's not about just getting to zero, it's about now we need to bring technologies that actually take us below zero, meaning we're bringing carbon out of the atmosphere, whether it's trees and plants, or carbon capture and storage, or other technologies. But we go beyond zero is what they start to bring into their pathways, and we'll see that. Progress in renewables needs to be mirrored in other sectors. We need to start taking carbon dioxide out of the atmosphere. That's what I'm talking about. You'll see that in their pathways. And then the implications for food security, ecosystems, and biodiversity. What they also concluded was the national pledges, and this is what Tyler already showed this morning, the IEA's, follow those pledges scenario doesn't get us there even to the 2. That was pretty obvious. And so the IEA has, here's what gets us to 2. And that's what they're saying here. We need to go beyond those pledges to get us to 1.5. And we need to start now. And this is back to the story. We need to start these things to decline substantially before 2030. Well, guess what? 2030 is only 10 years away. Yeah, it takes us 5 years to build an LNG plant. It takes us 5 years to permit one. Strengthening the global response in context of sustainable development and efforts to eradicate poverty. So this is the 3rd chapter in their study where they start to, let's get underneath this, under those 18 UN Sustainable Development Goals. So our close links to the United Nations Sustainable Development Goals, a mix of measures to adapt to climate change and reduce emissions, can have benefits. So a mix of measures to adapt for climate change and reduce emissions can have benefits for the Sustainable Development Goals. So they're saying those things are linked. All the other 18 things we want to achieve, they're linked to what we do with energy. And then national and subnational authorities, civil society, private sector, Indigenous peoples, and local communities can support ambitious action. And I think that's what I see here from this group, from the First Nations Climate Initiative. We want to understand this better so we can understand, so we can support the right action. The last bullet is pretty important because it came up in this report several times. And it talked about actually barriers to achieving the goals of 1.5. And this isn't a barrier. And that was global cooperation. That without global cooperation, we're not going to get there. Then they go, that's sort of the high-level summary. Then the report goes into the pathways, and then it goes into the impacts, and then it goes into sustainable development. So I'm going to take you through the pathways first. The pathways were modeled, all the latest and greatest climate modeling and energy modeling, similar to the IEA stuff that Tyler was talking about this morning, with slightly different goals and outputs, the 1.5 versus 2. And then they were also, there's a number of different things that impact it. One is reducing the CO2 emissions. The second is reducing what they call non-CO2 radiative forcing, which is other things in the atmosphere, maybe the methane, the carbon black, other things that get into the atmosphere, nitrous oxide. So they talk about a number of things participating in their pathways. And then they get to, and then they also have the impacts. And the impacts are in these bars. And here's kind of how they did it. So they looked at the ecosystem impacts. We're going to come back to the pathways, evidently. That wasn't the pathways section. That was the modeling section. But on the impacts, they start to look at different elements or risk. And so these bars show unique, if I can maybe help describe it, because the bar is basically 0 increase in temperature up to 2 degrees for a number of different ecosystem measures. If it goes from white to yellow, you're into what they call, indicates that impacts are detectable and attributable. If it goes from yellow to red, you're indicating, hey, we're going to have impacts, and they're going to be severe, and then very high. And then they do it for 1 degree, 1.5, 2 on a number of different what we call risk factors, unique and threatened systems, extreme weather events, distribution of impacts, global aggregate impacts, large-scale singular events. So this is more about events. And then down here was more about ecosystems, warm water coral, mangroves, small-scale latitude fisheries, Arctic region, terrestrial ecosystems, coastal flooding, fluvial flooding, crop yields, tourism, heat-related morbidity, and mortality. So those are all the bars they have, and they're measuring the difference between 1 degree, 1.5, and 2. And I think it gives you an idea of what things are more sensitive to the change. Because again, these are models, so there's a lot of assumptions and premises going in. But I think what it does show you is, to me, this looks all pretty consistent. There's not so big a difference. But in here, you'll see the warm water corals. Well, at 0.8 degrees, where we are today, we're already in the red for corals. So we know that's going to be an issue at 1.5, and we know it's going to be an issue at 2. So there's that one doesn't show. It shows we're in trouble already. Mangrove forests are look like a little more resilient, in that, we're good on mangroves at 1.5. Barely touching their yellow bar according to this modeling. At 2, yeah, we got some trouble. It's not the end of the world there. But if we were at 1.5, we would be in a much better place. And so it goes through all of these key issues that way. And Arctic region, clearly we've already know at 0.8 we're into some significant warming, because 0.8, as you and I know, is the average for the globe. If you actually look at the annual average temperature increase for the Arctic region, it's much more than 0.8. It's more like 3, I think. I don't know, help me out on this, guys. Tyler, was it 3 for the Arctic region? The average annual increase in temperature? It's more than 0.8. 0.8 is the global average. If we just look at the Arctic, it's probably more like 3, which obviously shows why we're having a yellow issue here already. And that only gets worse, of course. And so that's what they're showing. Terrestrial ecosystems, maybe a little more resilient. But it's, in the end, I think they painted a pretty dire story, and that's what kind of came out in the press when they released the report. It's like, yeah, we need to make it 1.5 now, that the risks are too great at 2. And so I felt that the report, when it was released, was more of a call for greater action. And and we saw a lot of press around that.
I read part of the report, and I'd like to just emphasize a couple of points that you made. The way I understand it, and I hope I'm wrong, I really do.
Alex.
The way I understand it, you just correct me if I say something that's incorrect. So this is 2 degrees across here, and this is 1.5. So I don't know what the question, I don't know what the answer is. Where are salmon? Okay, and I don't want you to answer that question right now, but that's a question that's pretty relevant on the coast. Like, how does salmon do? Because coral reefs are gone everywhere. As far as we can tell, at 2 degrees, they're gone. They might recover at 1.5, but they're gone at 2. A lot of this at 2 degrees is either red or purple. So flooding, terrestrial ecosystems, the Arctic, low latitude fisheries. Wonder what it is for West Coast fisheries without are there going to be any glaciers in British Columbia? I'm not trying to be hysterical. I'm just trying to emphasize that this is serious stuff. And the difference between 2 and 1.5 is huge. And and we're not even on track for 2. We're on track for like 3. And so what it is that this initiative is trying to do and grapple with is actually help Canada help the world get to 1.5. And it matters a lot to a lot of different people, including us. And if it's possible for us to bring this home in terms of, like, what are the prospects for glaciers in British Columbia? What are the prospects for salmon-bearing streams? Because that matters to us.
Yeah, I think those are good questions. I don't have all the answers here, but what I do know is that Canada has just completed a report on the impacts of climate change and global warming to Canada. It's just out. If you go on the government website, the Government of Canada website, it's just out. Greg Flacco, the guy we invited, was a key person involved in that study work as well. And in fact, I know that Greg briefed Prime Minister Trudeau on it. So he can answer those questions. I can't. I'm just a sort of an energy guy trying to, turn climate warrior, whatever. But we do know that we need to change. This is just more evidence. This is just to drill down what I just showed. So I guess I could have moved on the slide. So this is the top bar showing the extreme weather events and large-scale singular events. We really need someone here from that group to interpret this and give us more understanding on how they achieved these results. And then this is the same thing that Alex was just pointing to and going through. And so then they kind of boil it all down into the fact that the key transition between even 1.5 and 2 due to extreme shifts of biomez and doubling of tripling of number of plants, animals, or insects losing their climate and or ecosystem, their acceptable ecosystem. So yeah, so I mean I think the report was pretty dire. There's no happy place. It's scary, as we talked about at lunchtime. Some of this stuff is scary. And so this is another report providing that information, but we shouldn't kind of get frozen because of that. We need to now move on. What do we need to do then? What do we need to do and be part of the solution? So then the next part of the report goes more to the solution side of things. They do these pathways for modeling. How do we get to 1.5? And this is basically reducing the world's annual greenhouse gas emissions over time. So to Tyler's point, they're getting to zero anywhere between 2040 and 2070, depending on the modeling pathway. These guys did a lot of pathways. They modeled it out at 120 different modeling scenarios. And so that's all in the report. And then they start to boil it down into grouping the scenarios. And some of the scenarios have a what we call no or limited overshoot. And what that means is they get to 1.5 by just purely reducing emissions versus having to go beyond reducing emissions but sucking emissions out of the air and going negative carbon. So they talk about that in this report. We'll get to it. And then there's some pathways that have a higher overshoot, so then they have to use these tools, carbon capture and storage, forestry projects to suck carbon out of the air, carbon engineering technology from Squamish, BC, and they need to start to deploy these to get us back to 1.5. That's the higher overshoot. And so then you end up with this blue bar, and these are some of the other things that are contributors: methane, black carbon, and nitrous oxides. And then they take out of this 120 different pathways, they kind of pull out 4, 1, 2, 3, 4, P4, and we're going to look at those 4 illustrative model pathways. And here they are, and I'm going to take you through them. But the one thing about these pathways that's interesting is the blue line is global carbon emissions, and you'll see that they do go negative at 2060. And they go negative pretty much in all of them. But it's just a question of the longer you wait out here, the more negative you have to go over time and to hold at the 1.5. So the first scenario is very much a scenario around renewable energy. I think this thing is, we go big in on renewables, and so they're creating these scenarios. Whether they're realistic or not is another story, but they're saying if we go big in on all renewables, then we don't have to deal with as much carbon sequestration in the later part of the century. The gray is our emissions, basically from burning fossil fuel. The brown is forestry and land use change. So using our forests and changing how we use land to help pull carbon out of the atmosphere. And then the yellow is called bioenergy, carbon capture and storage. And that's like, we can use the trees to pull the CO2 out of the atmosphere, but then what we're going to do is we're actually going to cut the trees, we're going to use it to make energy, and then we're going to capture the CO2 again and put it into the ground. So we get double whammy. That's called bioenergy CCS. And nobody's really done it to commercial scale in the world yet. It's a bit of a dream, but to be honest, I believe that British Columbia is well positioned on this. We have a forestry sector, we have an upstream gas sector that knows about CCS, and we have infrastructure in place. So this isn't a pipe dream for BC. I honestly think this one is another area where we could be leaders and maybe sell our technology. Anyways, that's another story. So each of these scenarios has increasing amounts of sequestration. You'll see that. This is all in renewables early. This is built more around sustainability. It can't be just all about renewables. What about, you know, economic growth, clean energy for those that don't have it, clean water, jobs. So this, they start to move into more of a sustainable pathway. These two middle ones, I find, have a lot of sustainability checks. If you look at the 18 boxes and put them underneath each of these scenarios, which they did in the report, they say, okay, now let's line up the 18 sustainable development goals underneath these scenarios and see how many boxes get checked. So it was interesting that I think most of the boxes get checked in these middle two. And then out here on the end, this is kind of where you just keep doing what we're doing for quite a long time, and then we have to turn the switch and go massive into carbon sequestration and bioenergy with carbon capture and storage and whatnot. So I see this as, you know, being, you know, very, very difficult to achieve. And I also see, like, go all in on renewables right away, difficult to achieve too, just knowing the way the energy systems of the world are developed. But I did kind of like the middle two scenarios, and I thought there was quite something there. That's my personal take on it, so somebody else would have a different view. But and then it goes through the scenarios one by one. In scenario one, they talk about afforestation as a CDR, as a carbon dioxide reduction. And we are going to come back to that in one of our later sessions, I think, with some experts. They didn't look at fossil fuel carbon capture and storage in this scenario, or what they call BECCS CCS, where we use the forest to suck the carbon, then use them for energy, and then sequester the emissions from burning again. That's the BECCS. The second scenario had a broader focus on sustainability, including energy intensity, some of the things we're looking at here in British Columbia, human development, economic convergence, and international cooperation. So I like a lot of those words. They're the things that are going to get us there, as well as shifts towards sustainable, healthy consumption patterns. So we have to shift the way we use energy as well as just the type of energy. So, and then we also get into the land stuff. So we're touching into that on this scenario. And then the third one is like, okay, we're getting there a little slower because the technological development takes more time, and emission reductions are achieved in changing the way energy and products are produced, and to a lesser degree by reductions. But you'll see in that scenario, we do have a bigger role over time to this carbon capture and sequestration. And then the fourth scenario is where we're kind of late to the game. We just keep doing what we're doing, and then we have to miraculously turn it around with a large CCS investments globally. And then they have a big table on all this. But you know, there's some important stuff in the big table. And maybe I'll just point out a few things. And one of the things that's important, and people talk about, why don't we just go all in renewables? And I think what these four scenarios show you is, like, you do need to go all in renewables, pretty much on all four. And so that's the last one. So what these are showing is that there's the four scenarios. This is kind of the all-in renewables. This is a more sustainable. This is also sustainable, but allowing for technical change. And this is kind of late to the game, I would call it. The renewables, the change in renewables from today, from 2010 to 2030, so not from today, from a past point in time, you'll see that 400% increase, 470% increase, 300% increase. And then by 2050, even these two scenarios, renewables needs to be 1,300% increase. So in my, and you know what, and 878% increase. And this scenario, incidentally, actually lines up pretty good with the one that Tyler showed this morning, the IEA Sustainable Development Scenario. This one in the IPCC report mirrors that, very similar. And even there, it's showing 870% increase in renewables. If that's not all in, I don't know what is. And if they say, okay, well, why don't we just do it all, forget the gas? Well, if you forget the gas, then this number needs to be, instead of 870, it needs to be 1,500% increase in renewables. So it becomes a question of what is really doable, what is achievable. And that was the point that Tyler was making. So definitely I see on these scenarios, renewables is the big, it's big.
Can you speak to the gas in that scenario in P3?
Yeah. So then in the gas, we'll see the all-in renewables shows a massive reduction in a lot of fossil energy. In coal and in oil, reductions are down, and gas down 25%. But when you get into the middle scenarios in gas, they have anywhere from, gas is down 20% to it's up 33%. It's down in 2050 further. But that's where you see, when I look at this P3 scenario, it's very similar to the IEA, where what Tyler said this morning is even to meet the sustainable development solution, gas needs to be up by 20%. And so that's what these guys actually say as well. Here it is, 33 to 21% increase in gas between 30 and 2050.
And can I just jump in there for a second, Rod? The difference between P1 and P2 and P3 there is not that renewables are substituting for gas, at least by my read. It's actually that you have incredibly aggressive energy efficiency outcomes in P1 and P2. So you're really driving down primary energy demand with all the different kind of things like that. That's what's eating into the gas demand. You see, because it's similar renewable deployment across the three, if I'm not mistaken. So
Which row are you looking at?
So the bottom row, non-biomass renewables, 400, 400, 300, 800, 1300, 800. But you have much different gas outcomes between those three. And one of the main reasons is you're able to almost miraculously expand energy efficiency in P1 and P2, like way above what our historical levels of investment are.
Yeah, that's what's showing here. That they're saying P1 final energy demand is down 15 to 30%. So, whereas in the P2 they're saying, well, it's actually about flat. So even though the world's population grows, the energy use grows in China and India, we're able to, and efficiency grows at a fast enough rate that it's able to hold it flat. And then in P3 and P4, as they say, actually taking a little more of a world view, is like we actually can't keep it flat, so we need to do some other things. And we get into that. I actually haven't looked at the CCS stuff. But so the gas story is not so different in these middle scenarios than the IEA guys. What I found interesting was nuclear, having worked for the commission and permitted some of our mines in northern Saskatchewan. But basically what they're saying is if a 98% increase is a doubling of the world's nuclear capability by 2050. So that's a stretch. That's big. And unless we miraculously do the small modular reactors and make it much more deployable, that's a stretch. But and then 80% increase in nuclear. So there's a lot of stuff in here. Yeah, fossil goes down, but nuclear has to go up. Renewables has to go crazy. Gas is kind of steady Eddie in these middle scenarios. And I think what we learned this morning was, gas sort of stays 20% maybe up, but it's where the gas has to get to that's so important. It has to get to those big countries that are growing in population and energy use. And that's LNG to get us there. So I think one of the other things in this storyline that was jumped out at me was, I guess when we get into renewables, there's a story there about, and there's a story about electrification, renewable share in electricity. So I thought this was interesting. So there's where they want to be even in the end state, 2050, 77, 80, 60, 70. So let's call it 70 to 80% renewable energy in the world's grid. Well, we're already 80 to 85% in Canada. We're way ahead of the game on that particular metric. And so we can't work on that metric anymore. There's nothing left to do there for us. It's about some of these other things, helping the world in some of these other areas that's on our to-do list. They don't even talk about LNG in this report. It's just gas. Where does the world need gas and how much of it? So they haven't even touched into LNG. The IEA report gets into LNG. And so I think they would assume that the gas, that's a very good question. I don't know how much methane comes with the gas. I don't know what the upstream emissions would be with it. We would have to ask someone. Greg Flacco would be the guy. Yeah, or the other gentleman, Nathan Gillett. Yeah, Gillet or whatever.
Thanks.
Yeah, would be able to help on that, hopefully. Yeah, so I thought energy, renewable share, biomass. Biomass also going up in these, only in this sector. Biomass is here. And it generally is showing an increase in biomass energy. When we talk about CCS in this sense, I think they're just talking about removing carbon from industrial sources. They're not necessarily talking about using forests. That's in the next slide. So they're showing how much CCS we need. And all these scenarios, 3 of the 4 scenarios need massive amounts of this CCS, because as you recall, the later we wait, the more we need CCS. And then the other part of it was land and land use for bioenergy crops. So whether that's crops or trees. But I made a mental note. This is 0.9 million square kilometers. I think that's what that number is. It's square kilometers. So we need 0.9 million square kilometers. Call it 1 million square kilometers of additional bio crops. In this scenario, we need almost 3 million more square kilometers. And the area of British Columbia, just British Columbia, is about 1 million square kilometers. So we need a whole British Columbia area growing crops for fuel. And in this case scenario, we need 3 British Columbias growing crops for fuel. So I thought that was an interesting metric, because I'm not sure that British Columbia is into the crop business here, but maybe the other provinces in Canada could be part of that solution too.
What other scenarios do you have besides that? Been watching the news all the time with Australia and the United States burning, and they talk about millions of hectares and things like that. How does that fit into this picture when you start talking about crops and areas like that?
Well, I think these scenarios are, what do we need to do to get to 1.5? So it would assume that the United States and China and India, they're all playing ball, and they're contributing their part along with all the others, just as these metrics shows. So they would be putting in carbon capture storage, advancing renewables in a massive way, gas sort of staying flat, but we know it's more about where that gas ends up, particularly Asia, because they don't have any. So I don't know if that answers your question, but I assume that these scenarios assume that they're playing their fair share as well. Yeah. And Canada as well. And we're doing our thing. Yeah, I guess, well, we're making a start, but it'll be interesting, because I think as we get into this, you'll see that Canada's role, it's not so much about, Canada's only 1.4% of the global emissions, and BC's only 10% of that, so we're at 0.14. So For us to reduce our emissions by 40%, as we're setting our goal, or 80%, it's not having a big impact on the globe. It's important because it shows leadership and it shows that we understand the technology to get there. But where I think you'll see in BC's role and Canada's role, it's more about our products. It's more about our gas, getting it to them so they can reduce massive amounts. It's about getting our uranium to those who are going to actually go ahead and deploy small modular reactors and nuclear. It's about getting our forestry products to those that are converting from coal to biomass. Like, did you know that in the United Kingdom, they made a massive reduction in coal use as well, but they didn't do it through gas. They did it through converting to biomass. And guess where all the biomass comes from? British Columbia. So we can punch above our weight class, not by removing our 0.14 to 0.08, of the world's emissions, but by moving those products to those guys who can have the big hits. LNG is one of them. Biomass is one of them. Nuclear is one of them. I would argue that Brian comes from the mineral sector. What happens when the world builds all electric cars? There's going to be a lot of copper to spin. It's electric motors are copper, and where do you get copper? You get it out of the ground, and so they're going to be looking all over the world, where do I get my next copper? Canada has copper. And so we continually regardless of what we do, we continue to be a source of resources and raw materials to help the world get there. But we still need to develop those things in the most sustainable way and show leadership. We'll still always be challenged around, we can do our thing and contribute to the global reductions in a big way, but we always need to be showing we're still doing our homework at home, right? And so I think that's always got to be part of the storyline, that this thing can punch again way above our weight, and here's what we're doing at home too, to address our issues at home, because to produce this stuff for the world makes more emissions. And so here's what we're doing about that at home. So we got to build that better storyline there, which I think we're going to explore that as part of this whole initiative. And then the big story around global pathways is in this IPCC report. We need our storyline for British Columbia and our place in all of this. And I'm just presenting the IPCC stuff, and I agree, we need to build that. We need to build that story. And so I think we'll get there through these sessions. We're going to get more and more materials, and hopefully we can build that storyline. And not only just build it, it's like truly and believe it, that we understand the science and we believe this is the right thing to do. And here's the storyline, and here's the science to support it. More on this IPCC. Then they have this other thing. This is like Alex saying, this is hard reading. But when they get into this sustainability, what they do is then they look at the 18 or 17 key sustainable development indicators that the UN has essentially agreed upon. Everything from poverty alleviation, zero hunger, well-being, quality education, clean water, affordable energy and available energy. All these things are down here. And then they have these little bars that talk about the linkage. And so it doesn't really show it on here, but the bigger the bar and the darker the bar, the greater the linkage is to energy demand. In this case, they do energy supply, energy demand, and they looked at land. But for now, they focus on energy demand, and what you can see is 1, 2, 3, 4, 5, 6, 7, 8, 10 of the 18 have a very strong linkage. Those sustainable development goals, whether it's poverty alleviation, something that this group is wanting to talk about, and creating economic opportunities, health and well-being, clean water, affordable and clean energy for the world. So these things on the sustainability index are very strongly linked to energy demand. So I think that's really what this part of the study talks about, that you can't talk about sustainable development goals without talking about energy. The two are very closely linked.
The fact that they're weaving together mitigation of climate change with achieving the sustainable development goals, and you can still get to 1.5 and achieve the sustainable development goals. I mean, it's pretty incredible if that's possible.
And one of the other things that came out for me is that the synergies around land use and policies that affect land use, which is certainly an issue, near and dear to First Nations hearts, is also very strong linkage to those sustainable development goals. Very, very strong. So those were kind of my takeaways. It was, again, I'm not an expert in all of this UN, in the SD goals of the UN, but some of those things were pretty jumped out at me. So then what I wanted to do was just one more short presentation, and then I think I'm done. You're done with me. And which I'm trying to put this IPCC report a little bit more into context for us in British Columbia and Canada. I had written a paper, and after the IPCC report came out, I read the 700-page report, and then I made a lot of notes, and I did a bunch of thinking, and then I wrote a paper, what does it mean to Canada? And then I did submit it, but it was too long for an op-ed, so none of the papers picked it up, and they were all going for headlines, massive impacts and da-da-da. So what it means for Canada never got published, but I feel like I might still submit it. I have to decide where. But, and I think what the First Nation Climate Initiative has started here is very near and dear to my heart, because it talks about the power of our resources, the power of the resources from Canada playing a role to impact, to get us to 1.5. And so I'm going to take you through a few slides here, and then we'll just maybe then we can end with some discussion. So this was my first run at this, this piece. I did also read Greg Flacco. Flacco had presented to Prime Minister Justin Trudeau in 2015 after he took office on climate change and impacts for Canada and what does it mean for Canada. So I did review his presentation as well. He talks about the observed impacts in Canada, and we talked about that northern hemisphere, that we're taking the brunt of it. Just the way we are, our land mass, the tilt of the axis, and the impact, the seasonal impact on our ice. We are taking some of the impacts, and so he lists, this is from Greg's report, observed changes in Canada consistent with global changes, longer growing season for some areas on the prairies, for example, more heat waves and fewer cold spells, thawing permafrost. We talked about that as being one of those feedback loops. Earlier river ice breakup. That can be, for the north, a big issue. Like if you're relying on ice roads and frozen surfaces to move materials around, that has a big impact on your life. Increase in precipitation and earlier spring runoffs, earlier budding of trees, and then the prediction of weather, that it's just hard to predict. So that was kind of from Greg's piece. Then going back to this, so I wanted to come back to this because where are the emissions in the globe? Asia is a big hitter here, and so what can we do to help them? What can we do to help them? Because we are over here in this little box, and we in BC are only 10% of that box. So this is our little piece. So we can reduce ours here, but what does that do for the world? Well, it makes us feel good, but if it makes us feel good and none of us have jobs and ways to feed our families and incomes, then that's an issue. So we need to look at what can we do. We need to do some of this, but what we need to do is that. How do we help the big red bar go down? And even the US. But I think for us, on this side of Canada, the Pacific coast, it's about the big red bar. It's about moving stuff to Asia. And then this slide came out of probably an older IEA. Yeah, it's 2015. And it just talked about where all the growth in primary energy is happening. And so the big orange dot is the equivalent of what we just saw on the boxes. All the growth's happening in Asia. There's a pretty big good chunk here in South America, Africa, and then Middle East. And you can see North America growth is almost negligible. So we should be able to, in North America, reduce our footprint, but at the end of the day, it's about helping all these other balloons get smaller, and particularly that one. Now we go back to that sustainable development, sort of the 1.5 IPCC report, and one of their scenarios where it talks about we need to focus on sustainability, including energy intensity, human development, that's the Sustainable Development Goals, economic convergence, international cooperation. So these, to me, are all underpins for the case for BC. This is what we're trying to do here. We need all those things and reduce our emissions at home. That's the other part. It's an and. And then they talked about, and I showed you this already, close links to United Nations Sustainable Development Goals and international cooperation. This keeps popping up. So I think this is kind of the end of it for my presentation. But after all of that, looking at all that, it's like, yes, we need, what is Canada's role in the energy transition, whether it's 1.5 or 2? And I would extend that to BC. What is BC's role? It is to reduce emissions at home, to show leadership. But we know that that in itself is not going to help us get to the 1.5. That's more the leadership thing. But it's not only what do we want to show leadership, not only in our GHG reduction, but in our policy making. Being smart about the policies we put in place for BC and Canada. And policies that help us progress towards the sustainable development goals that were so important. So it has to be that balance. So that's where we need to show leadership. How do we get all three legs of that stool balancing each other? Second point, we're only 1.4% of global emissions. And if you look at BC, I think it's 0.14% or 0.14%. However, we have a wealth of resources that the world needs for the energy transition and a significant portion of landmass. We shouldn't forget how big a country Canada is and the landmass and the potential for carbon abatement that comes with that landmass. The boreal forest, it's a massive opportunity as well. Okay, we have, like, the landmass in BC is 1 million square kilometers, and what is it, 93% of it is crown land, which kind of infers forest. So then if you manage those forests better, I know I did a study with Blue Source towards the end of last year on climate mitigation technologies, and we looked at carbon abatement through forest management, replanting of forests that have been damaged by pine beetle and forest fire kill, and just taking better care of what we got there. It was massive. It's massive. For us, it was, he showed it, the Blue Source guys had it 6 million tons a year to 20 million tons a year by 20 million tons a year of carbon abatement through forests alone by 2030. Well, that's a pretty big reduction. So I guess my point is, yeah, we have some emissions to deal with if we're going to send LNG or gas over there, but there's other ways, and we can electrify and get that as small as we can, but there is ways to get to net zero. And Dave Nicolasian talked about on the phone, our goal is to be net zero. And that doesn't mean shut off LNG and shut off economic development, because the world needs our minerals, they need our copper, they need our uranium. We can't do it. We have to then think about other technologies to help bring that thing to zero. And that's this landmass stuff, this forestry stuff. And we're going to get into that later in these sessions, I think.
I find this slide very interesting because if I would hear the public narrative, I would hear that all of these industries are industries of the past and they're not going to help a clean economy, and we need new technology, and we all need to build computers. And this is wonderful because this tells a totally different story.
Well, I guess we've had a whole, whatever, 5 hours to kind of go through this stuff, and we understand the world needs energy. We get that. It helps meet our sustainable development goals. We'd like it to transition. There's different things that are needed to happen. And we here in Canada, so I say, the other thing is, this point here I make is IPCC Special Report 1.5. It kept saying over and over, a lack of global cooperation will be an impediment to arriving at the goal. And so if everybody says, let's just shut down all of our resource sector so we can meet our goal, well, guess what? Those resources don't reach the markets that need them. Yeah, they'll get gas. Maybe they'll get it from Qatar or maybe even the US, and it has a footprint that's, whatever it is, 25% higher than what we could have sent them. That's one example. So that's part of it. There needs to be this cooperation, and then that our resources are important. We talked about gas a lot. Uranium is interesting in the nuclear sector. Forestry, biomass, they're already buying that stuff from us, right? Everything we can give them. Minerals for electrification, that's copper, lithium, that's mining. They're going to be looking, as the world, 500% increase in renewable energy. Well, that means a lot more copper spinning, because that's a lot more electric motors. And where are they going to get the battery technology, minerals, and the copper for the motors, etc. Carbon capture and storage, we didn't talk much about this. I think it was Brian had asked, or someone had asked about it. And I did work on this for almost 10 years and saw one get built in Alberta. We have one in Saskatchewan. And I felt we were positioned to be world leaders. We haven't done anything in British Columbia yet. It would be nice to see something happen there. And I'm personally, it could be linked to the bioenergy side. Even if you took from a pulp and paper mill in Prince George, for example, has big pulp and paper mill. And they make those wood products, and it is a way to sequester carbon in wood when you use the wood. You harvest the tree, the wood goes to make products that are basically sequestering and holding the carbon, locking it in. But there's a fair amount of emissions from burning some of the bark and all the other parts that they don't use for their products. Well, if we capture the CO2 from that and put that underground, well, now we've got sort of double kick at the can. I talked about this earlier. The products sequester CO2 and our CCS would sequester CO2. That's called the bioenergy CCS. And I think we could be leaders, world leaders in that. I don't know if there's an appetite for it. It's also very expensive, but it's something that those curves showed we needed it in time. We need to get there in time. And then this whole idea of forest carbon sequestration, that could help us against as a reduction here at home, because we can't get our LNG to zero. So, for example, for shipping gas, we can't get it to zero. So we could do these kinds of things to reduce our emissions at home and help balance our own books to get to net zero. Those are an idea. But these are also exportable things, whether it's technology or resources. But to me, that's kind of what I was seeing from this thing, is the world needs to do all this stuff. We saw it in their scenarios. Hey, wait a minute, you look at our book, we're doing that, we have that resource, we have that resource. That's how we punch above our weight class. And then, so then I just close with Canada's role in achieving the 1.5 goal as identified in the IPCC is much more than just meeting its GHG target. Everybody gets focused on the target. And I'm not saying the target isn't important, but I'm just saying there's other things here that are just as important. So that was my take on it. Now that's my view, so I'm not endorsing that as IPCC's view. I did my own little analysis at the end on, as I looked through all the things the world needs to meet the goal, and it just so happens we have a lot of it. Now we can shut it all down and meet our goal and let somebody else provide it. That's called carbon leakage. And it's particularly a concern if those other guys can't do it near as well as us. Thanks very much for that, and thanks for putting up with me for 2 presentations today.